There isn't much that I really know, and there are very few things I'm actually good at. Maybe, through my past studies and work experience, I've spent a bit more time than others researching Cambridge thinking skills. So, if my efforts can help kids with the OC and selective school exams, I think that's enough for me. Alright, so today, let's start from here. Let's start from the very beginning, with the most basic topic, myself. I remember this was one of the first things I talked about. What is thinking skill? Unlike English, writing, or math, these subjects, right? Kids have more or less been exposed to them at school, haven't they? But thinking skill is the only thing that doesn't seem to have a dedicated class at school specifically called a thinking skill. So, for many parents and children, they feel that this subject isn't particularly easy to grasp, and they're not really sure what exactly is being tested. So today, through this introduction, I'm going to talk to everyone about what thinking skills mainly involve. What exactly is it? What does it mainly test in children? First, let's take a look at Cambridge's definition of thinking skills. In fact, Cambridge has a specific definition for it, and I've selected some highlights to share with everyone. First of all, thinking skills are divided into two main parts. One is called the critical thinking part, and the other is the problem-solving part. Later on, I will explain in detail what critical thinking is and what problem-solving is. Also, Cambridge makes it very clear that thinking skills are actually a transferable set of thinking skills that can be applied across a wide range of subjects. There are two key points here. First, it is a transferable set of thinking skills. It's a way of thinking, and more importantly, it's a set of thinking methods that can be referenced and applied elsewhere. In other words, when children are learning thinking skills today, it's not just for a specific subject, it's actually a way of thinking. At the same time, this way of thinking can help children in many different subjects. It will be beneficial in their studies across the board. For example, it can be helpful in math, chemistry, physics, and science in general. Why is that? Because what is being emphasized here is a method of thinking. This is a definition from Cambridge Singing School. So, some parents often ask me, "Teacher, will this be helpful for children when they study other subjects in the future?" I can say with certainty, absolutely yes, and it is extremely, extremely helpful. So, with my introduction below, you'll understand why this is also very helpful for children's learning in other subjects. First, let's look at the critical thinking part. What about the critical thinking part? Cambridge's requirement is that critical thinking is represented in 4 areas. First, you need to evaluate and use evidence. Second, analyze reasoning. Third, evaluate reasoning. And the fourth step is to construct reasoning yourself. You need to be able to build a good model of reasoning on your own. So here, maybe, for our selective exams, the main focus is probably on the first 2 points. One is evaluating and using evidence, and the second is analyzing reasoning. These are probably the 2 most important points in the selective stage exams. So what does it mean to evaluate and use evidence? Actually, it means assessing a piece of information, and this is really, really good practice for children. Because as we know, in the past, like when I was a child, or for parents around my age, we all know that the focus of education back then was much more on memorizing knowledge. Why was there such an emphasis on memorization? It was because, at that time, there was no internet, so getting information actually had a cost, a time cost, and it wasn't always convenient or accessible. There was a cost to it. So, if you wanted to handle information better, you had to memorize it. That's why, back then, we memorized a lot of things, because it was extremely useful. But now, times have changed. The problem kids face today isn't that they can't get information, but that they have access to too much information. Anything at all, you can just use Google or ChatGPT, you can easily grab tons and tons of information. So how do you evaluate and use all this information? That's the challenge kids will face as they grow up, no matter how old they get. So, thinking skills first test a child's ability to evaluate and use evidence. That's the core of the process. One important aspect is that you need to know how to carefully evaluate a piece of evidence from different perspectives, whether the evidence is truly sound or unsound, or how the same piece of evidence might look from various different angles. Break time equals 0.5s/. So from this perspective, argument and graphic reasoning are actually connected in some ways. When they give us a diagram and ask us to look at its front, its back, and its bottom, basically, it's just like an object that looks different depending on the angle you view it from. This is also a way of evaluating evidence. Okay, next is analyzing reasoning. If someone presents me with a line of reasoning, I need to be able to analyze whether that reasoning is correct or not, or whether it's reliable, or if there might be some issues with it. All of these are really great ways to cultivate critical thinking in children. This is the first major part. The second major part is actually proper problem solving. As you can see, it's all about what? It's about organizing information, processing information, analyzing information, and then using the experiences you have to solve broader problems. Actually, when it comes to exams, I think problem solving is one of the more difficult parts. At first, kids might feel that critical thinking is harder, but after some training, they'll realize that the real challenge lies in problem solving. Actually, the whole process of assessing kids is a series, it's a process, and these different steps ultimately help you solve a problem. So I often tell the kids, and a lot of parents ask me, what exactly is a problem? A so-called problem is actually just going from the information we know to the information we want to know. There's a gap, right? There's no instant solution there, and that's what we call a problem, right? For example, if I ask you what is 1 plus 1, and you say it's 2, no, would you call that a problem? No, because I know what 1 plus 1 is, and I want to know the answer, and the answer is 2. There's no gap in between, so that's not called a problem. A problem is when there's a gap between the information I know and the information I want to know. If I can't immediately get an answer, then in this situation, we need to organize all the information we have and process what we know. Then we analyze the information we have and finally arrive at an answer. At the same time, we can use the method or strategy we are using now to solve not just this problem, but also similar, yet different problems. This is the whole process of problem solving. So, thinking skills mainly assess these two aspects. And then, let's take a look at these two diagrams. I'm not sure if everyone can see them clearly, so let me zoom in for you. As you can see, this is actually from Cambridge's entire, well, there. This is a mind map taken from the teaching syllabus for thinking skills. You can see it's packed with information. You probably don't need to pay too much attention to all these details. What I want to say is that the entire Cambridge Thinking Skills course, the content inside is really, really extensive. The mind map I made here is based on my own study and understanding. Actually, in North America and in many other places, this is. How should I put it? It's actually a 3-year course. It's like 1 term, 2 terms each year, lasting for 3 years. This is a 3-term course, but actually, a lot of the content here is very relevant for our OC and select exams. It's actually not necessary, and it's a bit too difficult. So over the past few years, you could say that what I've been doing all along is subtraction, making reasonable reductions. What you can see today, in the second image, is a summary I've made of the selective course. It's a framework and key points for the exam, and we can take a closer look. This is also the basic outline I use for designing all my courses. So, using the outline of the thinking skills for this selective course, I've divided all the teaching content into 5 parts. For the critical thinking section, we've broken it down into 4 types of questions. These are argument, condition of statement, graphic reasoning, and logical sequence. So, we've mainly divided it into these 4 types. 1, 2, 3, 4. These are the main categories under critical thinking. Next, moving on, the other major category is problem solving. And to make it easier for the students to learn systematically, under each major category, I've further divided them into several smaller question types. For example, with argument, the first thing we often need to do is argument analysis. That is, we need to be able to identify the different factors of an argument. That's the first one. The second is that we need to know how to strengthen and weaken. This is a very common type of question that we get tested on. The third one is fallacy. And finally, there's also assumption, which is something we absolutely need to understand when it comes to arguments. I further divided argument into 4 smaller question types. Similarly, for conditionals, we've also broken them down into different types, including one diagram, conditional chain, and the typical NICC question. In the same way, we've divided this into 4 different subcategories. Likewise, for graphs, we've split them into 7 different sections to introduce some basic effects about graphics to the students. As for logical sequencing, it's the same. In the larger section of problem solving, the focus is mainly on some common strategies. That is, what common strategies do we often use? For students, this is actually a very good kind of thinking training, meaning that what they really need to master is more of a method. Compared to math, it doesn't always require specific math knowledge for every question. Of course, some questions do require certain math skills, but for others, it's more about how you approach and think through the problem. Here, I often give everyone an example, which is a type of question like, when it's raining, should you run faster to get across? Will I get less wet if I run, or should I just walk at my normal pace to avoid getting as wet over the same distance? So in this situation, which one is actually better? Some people say you should run, but others argue that if you run, more raindrops will hit you. Actually, you might not end up getting less wet than someone who just walks. So, it seems like both arguments make sense, right? Which one is actually correct then? How should we go about thinking through this problem? You'll notice that this question doesn't really require any math knowledge, right? It's really more about the way you approach and think about the problem. Right? We call this kind of thing extreme cases. So when I don't know the answer, one common way of thinking is to push the problem to an extreme case. Take this question, for example, even though I don't know whether running fast or just walking is better, I can push the situation to the limit. So think about it. What happens if you take running to the extreme? Pushing it to the extreme means you run faster than light, right? Right? That is, before the raindrops even fall, you've already reached your destination, so you wouldn't get wet at all. Seriously, theoretically we say that's true, right? Now, on the other hand, if you just walk. Now, if you push walking to the other extreme, what does that mean? It means you just stand there without moving, right? In that case, you'll get completely soaked, right? So from this, it seems that the faster you go, the less rain you'll get on you. That's why, when it rains, you should still run a bit. This question itself doesn't actually involve any mathematical knowledge, but it really is a way of thinking about problems. And this way of thinking actually has many other applications, including what we often talk about. Parents often mention to me things like they're a chicken and rabbit in the same cage problem, or they're a chicken and dogs question. At its core, these are also examples of using extreme cases. You're basically pushing a condition to its limit. When you assume they're all dogs, right? That's when there are the most legs. Or when you assume they're all chickens, that's when there are the fewest legs, right? You're pushing it to an extreme, and then you make substitutions. So these ways of thinking are exactly what we cover in class. We need to systematically present these ideas to the kids. Because if you don't help them summarize this, even if they understand it this time, next time they might not. Maybe if the question changes, he won't be able to recall it, and he won't be able to build up that kind of accumulation. But when you lay out these commonly used strategies for him in a systematic way, we can group all these similar things together for the kids. That way, the child realizes, oh, so this is a method. Also, I want to remind all the parents here that doing thinking skills questions is completely different from doing math problems. I am especially against having kids just do endless practice questions. Because just doing lots of questions makes it very hard to develop the right way of thinking. To truly build the correct way of thinking, you have to get your child to focus on the questions they got wrong and ask themselves, why did this question turn out this way? What we often ask in class is a why. We frequently ask the kids a why, and it's through this process of constantly asking a why that they gradually develop a way of thinking. Alright, so that's basically what I wanted to share with everyone today about what thinking skills actually teach and what kinds of things are tested, just a general overview of these topics. In the future, I'll use other opportunities to talk with you in more detail about how we design these courses during the children's learning process, and how we can better help the kids. To learn thinking skills. Alright, that's all for today's content. I'm really glad to have had another chance to sit here and share with everyone. It feels great. Thank you all.